Hello everyone. In this video, we are going to revisit a concept we mentioned earlier, downcasting. You can see here we left two nodes. One is dynamic cast and the other is static cast. So what's the difference between the two? Both are used to convert an object into its derived form. However, the way they check the validity of the conversion is different, and that's what distinguishes them. Static cast performs its checks at compile time, but compilers aren't always smart enough to guarantee that every conversion is truly safe. For example, let's look at this code. Okay, here we declared an employee object and then directly cast it into an engineer. Afterward, we call member functions that only engineer has. This is risky because the object wasn't originally an engineer. If you were to use this style of casting inside the showSalary interface function, which relies on polymorphism, it might still compile or even run, but it risks crashing your program. Let's try it and see what happens. A better practice is to check the object type first before performing the conversions. To do this, let's make a small modification in our head file. Okay, the first thing we need to do is move the type member variable into the base class. Okay, and also define a getType function in base class. Finally, update the constructors of all derived classes accordingly. Okay, let's try it. Okay, now back in main function, we can add a safeguard check with getType like this. This way, we first check if the object is of type engineer before converting. As you can see, there's no output. Okay, so how can we apply these concepts to the function showSalary interface? We can right-click like this. Okay, here we create an employee and an engineer, set their salaries, and push them into a list. When passed to show salary interface, the loop checks each object's types and performs the correct cast before calling the right function. Okay, let's run this and see what happens. Perfect. Now let's talk about dynamic cast and see another simplified example. As mentioned earlier, static cast checks conversion at compile time. In contrast, dynamic cast checks them at runtime. This means you don't need to check the object type manually beforehand. Instead, after attempted the cast, you just check if the resulted pointer is null pointer or not. If it is not, then the conversion was successful. Okay, and there's an important prerequisite. To use dynamic cast, the base must be abstract, meaning it must have at least one pure virtual function. Okay, and since employee is an abstract class, so we cannot declare it directly. Okay, after this change, we run the program and see what happens. Okay, as you can see, it prints this line's output. Okay, both static cast and dynamic cast rely on polymorphism to convert base class objects into derived class objects. Which one to use depends on the design of your system architecture. Okay, in the next video, we will move on to templates, a new topic that builds on everything we have been learning. See you in the next video.